Okay. A plank AB 3.0 meters long, weighing 20 kilograms, and with its center of gravity 2.0 meters from the end A. This is the end here. It carries a load of mass 10 kilograms at the end A. So this is the mass here, 10 kilograms. It rests on two supports at C and D. So this is C and this is D. So these are the two supports. The supports are known as knife edge. Are we following? They are known as knife edge. Okay, one, we have to compute the values of the reaction forces R1 and R2 at C and D. So you can see the reaction forces here. Now the reaction forces are the forces that are acting upwards because of the weight of the beam and the force that is what? Added here, the mass that is added here. So the forces are acting downward. This one is acting downward, and the weight of the object is also acting what? Downward. Now to approach this kind of a problem, what you are going to do is to draw a straight line to represent the plank. So draw a straight line and put A here and put B here. We are going to convert all masses to what? Weight. We are going to convert all the masses to what? Weight. So this is 10 kilograms. So that's going to be 10 times 10. That is what? 100 Newton. So the weight that is placed there. So you are going to use arrow diagrams to show this. So we have 100 Newton. Now there is a pivot here, or knife edge, or a support here. So this is support C, and include the reaction R1. Okay, let me place the other support D, and the reaction is what? R2. Now the distance from A to C is 50 cm. So we have to convert all of that to what? Meters. So we divide 50 by 100, that gives us what? 0.5. So the distance is 0.5 meters. And for this also, it's going to be what? 0.5 meters, because they're exactly the same. 0.5 meters. Now the distance between C and D is what? 2.0 meters. So let's include that. 2.0 meters. Now, we need to include the weight of the plank. We are told that the plank is 3.0 meters long. And the weight of the center of gravity of the plank is at what? At the 2.0 meters mark. Now what that tells us is that the plank is not a uniform plank. If the plank is a uniform plank, the weight of the plank will be at the midpoint of what? The plank will be at the center of what? The plank. Now you see that it is 3 meters long, but the center of gravity is closer to this other end than end A, right? So what we are going to do is to just include this here. Draw a line from the, let's say here, and put the distance from here to here is what? 2.0 what? Meters. Now if from here to here is 0.5 meters, then from here to here will be what? 2 minus 0.5. And that will give us what? That gives us what?
That gives us 1.5.
So 1.5 meters. So these are the distance between C and this point here. Let me call this G, which is the center of gravity. 1.5 meters. So the weight of the object is, the mass of the object is 20 kilograms. We have to convert that to what? To what?
Weight.
Newton. We have to convert to weight, which is in what? Newton. So we multiply this by 10, and that gives us what? 200 Newton. So we have that. There are no any other forces that are here again. So these are the forces that we have here. Now, they said we should compute the values of the reaction forces R1 and R2 at C and what? D. So this beam or plank is in equilibrium. Now, since the plank is in equilibrium, for equilibrium, we know that the total upward forces is equal to what? The total downward forces. Okay? The total upward forces is equal to what? The total, because the beam is in what? In equilibrium. Now, the upward forces are R1 and what? R2. So we have R1 plus R2 is equal to, the downward forces are what? 100 Newton and 200 Newton. So we add them together. 100 plus 100.
100 plus 200.
Sorry, 100 plus 200. That's what? 300 Newton. So let me just move. We'll call this equation what? 1. Are we following? In all of this, what we are doing is to calculate what? The reactions R1 and what? R2. So the next thing we have to do is to take moment. Because it is in equilibrium, are we listening? Because it is in equilibrium, we have to take moment about any of these points. We can take moment about point C or point what? D. So let's see. Taking moment about, so I'll take moment about point C. So taking moment about C, we are going to have this. Now let's look at the clockwise and anti-clockwise movement. Now we are going to determine our clockwise and anti-clockwise movement based on the fact that we are taking moment about point what? C. Based on the fact that we are taking moment about point what? C. Now if I take moment about this point, this force is going to rotate this plank in this direction, right? So what direction is this? Anti-clockwise, right? This will rotate this thing in this direction, that is anti-clockwise. Now, what about this force? If I take moment about this point, this force is going to rotate this in this direction, is that not?
Yes, sir.
What direction is that?
Clockwise.
Clockwise. Then we have this force. If I take moment about this is going to rotate this thing in what direction? This direction, right?
Yes.
What direction is that?
Anti-clockwise.
Anti-clockwise. Okay. So we have been able to determine the clockwise and anti-clockwise moments. Now, for equilibrium, because the beam is in equilibrium, it means that the sum of the clockwise moment must be equal to what? The sum of what? The
Anti-clockwise moment.
So our clockwise moment is the 200 Newton, is that not?
Yes, sir.
So that be 200 times 1.5.
1.5.
That gives us what?
300.
300 is equal to, now this is 100, the perpendicular distance is what? 0.5. So 100 times 0.5 is 50 plus, now the remaining anti-clockwise moment is R2.
Yes.
The distance of R2 from C is what?
2.0.
So 2 times R2 will be what? 2R2. Are we good? So now let's look at this. We want to make R the subject of formula. So we'll move this way. We have 300 minus 50 is equal to what? 202. 250 is equal to what? 202. So R is equal to what?
125.
250 divided by 2,
which is
equal to what?
125 Newton. Oh, shit.
Now, can we look for, we have got R2 now, right? So can we look for R1?
Yeah.
So R1 is going to be equal to what? 300 minus what? R2, right?
125.
We are making this the subject of the formula. Minus R2. So R1 is equal to 300 minus R2 is what?
125.
So subtract that from me. R1 is equal to what?
175.
175 Newton. So it means that R1 is equal to what? 175 Newton. And R2 is equal to what?
125 Newton.
So we have calculated this and we have obtained our what? So we have calculated for R1 and R2. Next, we have to go to part 2. How far from D and on which side of it must a mass of 24 kilograms be placed on the plank so as to make the reactions equal. Now what we want to do is this. Okay. Now, what we need to do is this. We are going to make use of this diagram and include the 24 what?
Kilogram.
But this time around, the reactions are set to be what? Equal. So since the reactions are equal, the reactions are just going to be what? Arrow and what? Arrow. Because they are what? Equal to what? Each other. So let's take the 24 kilogram and convert it to what? Weight. That makes it 240 what? Newton. Now the beauty of it is that you can place that mass anywhere on this because we don't know the position we want to place it. But let me place it here. I want to place it here. So if I think that will give me what? 240 what?
Newton.
Right?
Yes.
Now, I'm still going to take moment about C. So if I take moment about C, what will be the direction of this? Let's listen now.
It will be clockwise.
It will be what?
Clockwise.
In this direction, right? Yeah. So the next thing we have to do now is this. Now, they also ask us to find what? They ask us to find what?
Their values of the reaction.
So now let's look at this. So if I take moment about this will also be what? In the anti-clockwise
direction. Yes.
Now, for equilibrium, upward forces
plus downward
is
forces.
equal to what?
Downward forces.
Downward forces. So the upward force is what? Arrow plus what? Arrow, is that not? Now the two arrow is equal to what? The downward forces are what?
100
plus 240 plus 200. We converted it to Newton plus kilogram. So that's what?
200
Plus 240 plus 100. What's that now?
340
Plus 200.
540
540. So that is 540. So what is arrow? Arrow is
540 divided by 2.
divided by 2. That's equal to what?
270.
270 Newton. So the reactions are what? 270 what?
Newton.
Now the question they ask us is, from D, what position are we going to put this 24 kilogram mass? From what? D. Are we following? So what we are going to do is, since we are taking moment from this, I'll just choose a distance between this and this. Are we following?
Yes.
So let's call that distance what?
X.
So now let's take moment again. So taking moment about C. Taking moment about C again. So if we take moment about point C, where our clockwise moment are what? This and this. And our anti-clockwise moment are what?
This and that.
This. So the sum of clockwise moment. So we are going to have what? 240 times what?
X. 240x.
240x plus 200 times 1.5. That's 300, right?
Yes.
Is equal to anti-clockwise moment. 100 times 0.5. That's 50, right? Plus arrow times 2.0. What's arrow?
R is 270 times 2.0.
That's 540.
540.
Right?
540, yes.
So 240x is equal to what?
540.
540
590
minus 300.
Right? When you add this and together, you get 590. So 240x is equal to what?
290.
290.
Divide
So
both
x is equal to
sides.
what?
290 over 240.
That gives us what?
1.20.
1.20 what?
8.
8. So let's calculate 1.21
1.
meters. So you see that this x is 1.21 meters from what?
C.
But we are asked what will be the distance from what? D, right? Now let's see. This is the distance from D. Let's say the distance from D is y, right? If the distance from D is y, what is the total distance from C to D? 2, right? So x plus y is equal to what? 2. Right?
Yeah.
So x plus y is equal to what? 2. What is x?
1.21.
Plus y is equal to what? 2.
2.
So therefore,
Y is equal to 2 minus 1.21.
that gives us what?
0.79
meters. Now you can see that this 240 240 Newton weight is 0.79 meters from D and what on the left side, isn't it? So therefore, the 24 kilogram mass is what? 0.79 meters on the left side of what? D.
Yes.
Okay, now let's go to the last part. Now, they said without this 24 kilogram, without the 24 kilogram, what vertical force applied at B will just leave the plant clear of what? D. What is the reaction at C? At C. The reaction at C, not D. Because, now let me explain that. Draw the plant again and include all the forces. This is 100 Newton, right?
Yes.
This is 0.5.
5.
This is, okay, now I will exclude this. Do you know why I want to exclude that? Because that they said that we will put a force at B to remove the what? Plant from what?
D.
From this support, the diamond. If you remove the plant from the support, there will be no reaction at where? At D again. The reaction here becomes what? Zero. Are we following? So there's no support there. So I'll put my force here, vertical force upward. Let's call that F. But there will still be a reaction here. That reaction is what?
R.
R. Are we following? Now we'll see mark out all the distances. Now look at this. The distance will now, okay, we have the weight of the object, which is 200 Newton. Am I right?
Yes.
And we know that the distance from this to this is what? 1.5.
1.5.
Our distance, isn't it?
Yes.
Now, what we now need to do is to get the distance between C and what? D.
D.
This is A, right? Because remember that the 24 kilograms is no longer what? There, isn't it?
Yeah.
So let's get the distance between C and B. The whole length of the beam is what?
3.0 meters.
The whole length of the beam is what?
3.0
3.0
meters.
meters. 3.0 meters, and from here to here is what?
0.5.
So what will be from here to here? 3.0
Minus
what?
0.5.
And that gives us what?
2.5.
So 2.5 meters. So this is what we need. Now, we know that, again, we know that upward forces, because it is in equilibrium, upward forces is what the what?
Downward forces.
Downward
Forces.
So the upward forces are what? Arrow and what? F.
F.
So arrow plus F is what the downward forces are what?
100 and 200.
100 plus 200 is what?
300.
So we call that equation 1 again as what?
Usual.
Now let's take a moment about what?
C.
So let's determine our clockwise and anti-clockwise. This one will what?
Clockwise.
So I take a moment about C. So this is what? Anti-clockwise.
Anti-clockwise.
And this one is what?
Clockwise.
This one is what?
Anti-clockwise.
Anti-clockwise. Abi?
Yeah.
Anti-clockwise. So now if you take a moment about C, taking
Moment
moment
about C.
about C, it is very important for you to state where you are taking on what?
Moment from.
Because I can also take moment from here.
Yes.
I will follow it. You must state it and determine your clockwise and anti-clockwise direction based on where you are taking what? Moment from. If I take moment about B, the direction of this moment will what? Change. Are we following?
Yeah.
Okay, so let's see. Clockwise moment is equal to what? Anti-clockwise moment. What's our clockwise moment?
300. 200. That's 1.5.
That's 300. Is equal to anti-clockwise moment. 100 times what?
0.5.
That's 50 plus
150.
plus F times what?
2.5.
That will give us what?
2.5 F.
Do you get that now? So let's see, 300 minus 50 is equal to what? 2.51 F. When you supply this one, that gives me what? 250 is equal to what? 2.5 F. So what will be F? F is equal to 247 divided by 2.5. Divide it. 250 no, divided by 250 divided by 2.5. 150. What is 100 what?
Newton.
Now what is, how do I get arrow? From here, from equation 1, arrow is equal to what? 300 minus what? F, Abi? Isn't it?
Yes.
So what's arrow? Arrow is equal to what? 300 minus F is
100.
what? 100.
100.
200.
So that gives us what?
200.
200 what?
Newton.
So we can see that arrow is what?
200 Newton.
And F is equal to what?
100
Newton. So that's what they asked us to do. They said, without this 24 kilogram, what vertical force applied at B, we just split the clear off what D. The vertical force is what? Is 100 Newton. And what is the reaction at C? So the reaction at C is what? 200 what? Newton. Okay.